Hi and welcome to another product presentation from TIS. Today we're going to be looking at our new EVSE testing kit, which is our TIS MFTECO EV. Just wanted to take you through a few features and benefits and take you through a full testing procedure using a Zappi EVSE charging station. So let's get on with the testing. Black lead goes into B1 on the TIS MFTECO, green lead goes into the B3 and the blue lead goes into B4. And then in conjunction with your TIS EV-TEST100, blue lead into the PE and the black lead into the load out on the PE to perform the continuity test. Select into continuity and simply press go. Continuity test is done, 0.09 of an ohm, and it's delivered 210 milliamps. On to the insulation test. Now we need to introduce the green lead. So we move the blue lead into the blue connection in the EV adapter, green into the PE, and remove the B1 that was in the load out PE, and we put that into L1. Still not touching the dial, so the PP state still set to NC, CP set to A, and the status is set to OK. So we're going to perform two insulation tests. The first insulation test is live to earth at 250 volt. So 499 megohms, delivered 260 volts. Move across and change it to neutral to earth and press go. Greater than 499 megohms and delivered 260 volts. So that's the insulation test done. We're now going to go and do some fault status with the pod. So as you can see at the minute, there's no voltage, no frequency coming into this pod at this minute in time. But if I turn my CP state to B and change my PP state to 13 amps, that now will have locked the type 2 connector into the Zappi, and I now can't pull that out. So that's confirmed that it's now locked in. If I change my CP state now to C, you'll see on the MFTECO there's now a charge coming from the Zappi, and it would charge your car at this point. So it's delivering 235 volts. So we're now going to drop an earth fault on and see what happens. So we can hear the Zappi click out, but also the MFTECO confirms on the screen that the voltage has died and now the pod is dead. We can move it to an electrical fault. And again, you can see that the EVSE charging station has not re-energized and it's still dead. So the electrical fault and the earth fault, should that occur, the pod will detect that and switch off. Move the status back to OK. So it livens the pod back up. And we're now going to perform a loop impedance test. Live to neutral result is coming at 0.67 of an ohm. Just wait for the live to earth. Live to earth result 0.62 of an ohm. So the loop test is good. Now we're going to perform a ramp test. So a ramp test, and we're going to perform that at a type A at 30 milliamp. Press go. The Zappi's confirmed that the type A has tripped. It's gone out at 122 milliseconds. I'm just going to reset the pod. Now we're going to do a ramp test, and we're going to do it at 6 milliamp, and you'll see a new feature with the MFTECO that actually now we can test an RDC-DD device. That is a residual direct current detecting device. 95% of EVSE chargers out there on the market actually use this device due to costs and obviously size. So with the MFTECO we can actually test the device correctly. You can test type B as well, so if you do come across EVSE charging stations with a type B, it will test that as well as the RDC-DD. So we're good to go. You'll notice it's a slow ramp test compared to probably a usual ramp test that you've seen. It's tripped, it's gone out at 829 milliseconds, which was within specification of the RDC device. So we've just fully tested the EVSE charging station from continuity up to RCD. Hopefully you've found the video informative, and thanks as always for watching. Thank you.